Hello class. So we're back again talking about equations with variables on both sides. So this is the second half of the lesson that I told you that we were going to look at. So let's just kind of review the first half real fast and then we'll move on into the second step. Okay, so we know that we're talking about equations with variables on both sides. So this was one of the examples that we worked yesterday. Okay, and we know that when we're dealing with equations with variables on both sides, there's three basic steps. Get the letters on one side of the equal sign. How do I do that? I add the opposite. Get the numbers on the other side of the equal sign. How do I do that? Again, add the opposite. Now, it doesn't say get the letters on the left or get the letters on the right. It just says to one side. So it doesn't really matter which side you move them on. Just whatever side you move your letters on, the numbers have to be on the other side. And then last but not least, we solve, because you're going to have either a multiply or a divide problem. Now, yesterday we talked about a couple of instances that could happen. Your variables could disappear. They could be eliminated. And if they're eliminated and it makes a false statement, then we cross out the equal sign and we write no solution. Because if the variables in an equation are eliminated and the resulting statement is false, the equation has no solution. Now, you could also have equations where the variables are eliminated, but it makes a true statement. So if it makes a true statement, we say that all real numbers work, because every number that I plug into that equation is going to make things happen. So today I want to look at a few different things that could go on. You could have fractions. You could just have word problems. You could have a geometry problem. So I want to talk about how we solve each one of those. So in this one right here, if you'll notice, it's the same exact thing that we have had. It's just now we got fractions to deal with. So you could convert those to decimals, and that would work. Since we've got a denominator of 4, it will give me a nice pretty decimal. It won't be that bad. It won't be repeating. But I choose to just keep it as a fraction. So we're still going to go through the same steps. Step number 1, get my letters on one side. Now for me personally, like I've said in class, I like moving my letters over to the left. So that's what I'm going to do every single time. So here I've got a negative 5/4 x. So in order to move that, I'm going to add a positive 5/4 x. So 5/4 x. And if I add that to one side, I'm going to add that to the other side as well. So we've got 3/4 x plus 5/4 x. Well, since we have a common denominator, I just have to add my numerators. I end up with 8/4 x, which is really, when you simplify it down, just 2x. And then I bring the 2 down. My 5/4 x cross out, and I'm left with 8 on the right-hand side. So a lot of times when you are given fraction problems, they'll turn out fairly decent, because we're just having you use those rules to show you that you can use other numbers besides just whole numbers. Now I need to move the 2 over to be with the 8. So I subtract 2 from the left, subtract 2 from the right, and you're left with 2x is equal to 6, because the 2's are eliminated. So now I divide by 2, and I end up with x is equal to 3. Simple as that. Okay, so that's how you can solve a question whenever you've got fractions in there, or you could have decimals. The process is still exactly the same. It doesn't change anything. Now, what if we have a word problem? Now, in a word problem, what I'm expecting you to do is write an equation and then solve it. Now, in this particular one, what we're going to do is we're just going to write the equation and then simplify it down as best we need to. But we're not going to take the time to just solve the problem. We'll do that in class. So in this one here, it says Daisy's Flowers sell a rose bouquet for $39.95 plus $2.95 for every rose. A competing florist sells a similar bouquet for $26 plus $4.50 for every rose. Find the number of roses that would make both florist bouquets cost the same. So we've got two flower shops here. We've got Daisy's Flowers, and they're going to sell flowers for $39.95 plus $2.95 per every rose. Okay, so what we want to do is we want to write an expression for that. So we're looking for two things. I'm looking for a number that I'm going to multiply by a variable, or in other words, I'm going to increment it over and over and over again. And I'm looking for a number that's going to stay the same each time. So in this particular one, Daisy's Flowers is going to be, the constant's going to be $39.95. So I'm going to pay $39.95 for the bouquet. That gives me all the extra flowers. Now, if I want roses in there, I got to buy those extra, and they come at $2.95 per rose. So add to this price $2.95 per rose. And we'll just use an R for rose. Now the competing florist sells a similar bouquet, but they're going to be $26 plus $4.50 for every rose. Now what we want to look for is what number of roses would make both florist bouquets cost the same price. So I want to take this one on the left and the one on the right, and I want them to be equal to each other. Now what you'll notice is that's nothing but an equation with a variable on both sides. So we start by getting all of our letters on one side, our numbers on the other, and we solve. And when we're done, basically what that is that will give us the cost, or that will give us the cost of or give us the number of roses that would give us the equal price because of that equal sign in the middle. Simple as that, okay? The process then is still the same once you write the equation. So here's a geometry problem that we could use. It says write an equation to find the value of x so that each pair of polygons has the same perimeter. So we have to understand perimeter means the distance around. So what we've got to do is we've got to create an equation so that I'm finding the perimeter of each figure. And I'm trying to figure out which number, what value of x could I have that would give each of these figures the same perimeter. Well, we know perimeter is side plus side plus side if it's a triangle. If it's a rectangle, it's going to be side plus side plus side plus side. So in this one right here, we're going to say x plus 6 plus x plus 3 plus x plus 9 will give me the perimeter of my triangle, because that's going to say this side plus this side plus this side. That's our perimeter. Now on a rectangle, we're going to do the same exact thing. We're going to have x plus 4 plus x plus 1 plus, now since the opposite side was x plus 4, that side's going to be x plus 4 plus, and then again, x plus 1. And now what we do, we want to figure out what value of x would make these two perimeters the same. So we're going to put an equal sign in the middle of that. Now what we do is we can simplify this particular expression to make it a little bit easier to understand. If you'll notice, we've got an x and an x and an x. So on the left-hand side, that gives me 3x plus, and then you've got a 6 and a 3 and a 9, which is going to give me 18. So that left-hand side will simplify down to 3x plus 18. And we want to do the same thing to the right-hand side. So I've got an x and an x and an x and an x. So that's going to give me 4x plus, and a 4 and a 1 and a 4 and a 1, which is going to give me a 10. So now that I've simplified that down, I have just a regular equation with variables on both sides. And when you solve that, you will find the value of x. Now, with that value of x, we then can find the value of each side of each polygon. Okay, so that's all we're doing really when we're doing these. Okay, so let's look at one more word problem, and then we'll call this one a day. It says you are seeking an emancipation from your parents. You're looking for an apartment. There are two final choices. Apartment A has a $1,000 security deposit, and it's going to cost $1,200 each month. Apartment B has a $1,500 security deposit and costs $1,175 each month. So how many months M will it take for the cost to be the same? So if we look at that first apartment, apartment A, so I'm looking for a number that's going to stay the same and a number that I'm going to increment each time. Okay, so in this one right here, we know we're going to pay $1,200 each month. So that means we got $1,200 M. Right? And then I'm going to add to that the $1,000 security deposit that I have to pay up front. Now, the other apartment says I'm going to pay $1,175 per month, but I'm going to have to pay a $1,500 security deposit. And it says, how many months M will it take for the costs to be the same? So that means I'm looking for equals. So that's taking an equation from a scenario and then writing all the equation from that. And then all we have to do is solve it. Now in this particular one, whenever I get done, what I'm going to do is I'm going to have a label of months on my answer, because the question is asking for how many months will it take for the cost to be the same? And that's really what we're doing in this particular lesson, learning different methods or different ways problems can be presented to you that deal with an algebraic equation. So until next time, I'll talk to you later.